Hey everybody, this is getting started on the equilibrium problems. So I'm going to come down here. So we've got nitrogen gas plus 3 moles of hydrogen gas are going to form into 2 moles of ammonia gas. And then plus now where it says 22.2 kilocal, let's just annotate that. Hopefully I got this here. Let me go there. That is heat, okay? Heat. So just add heat up there so we know we're talking about heat. Okay, this isn't easy to do. Heat. Oh, okay. So there we go. Also, you can go ahead and cross off this column. We're not going to do that. And we're only doing 1 through, I think it was 8. It says in the directions. So what we've got here is, here's our reaction. And it says, here's the stress. We're going to add N2. So we're going to add stuff up here. So I'm going to say we're just going to dump a big container of nitrogen up here. And in the earlier video, I talked about if you kind of imagine when you're at equilibrium, this is a flat teeter-totter. If we add stuff over here, the teeter-totter is going to drop at this end, which means you've got to shift things, to the right. So that's right here. You can either put an R or you can even just put an arrow saying to the right. So that's what's going to happen if you add N2. Now, if you add N2 and it shifts to the right, what's going to start happening is you're going to use up any nitrogen and hydrogen, and it's going to start making more of the ammonia. So that's why over here it says the ammonia increases. So you can either put increases or an up arrow. Now over here, because this is one of the reactants, as we add this nitrogen, that extra nitrogen is going to use up whatever hydrogen's there, and the concentration of hydrogen is going to decrease. We're going to use up hydrogen, so it's going to go down. Okay, so that's how you'll do these problems. So, I don't know if I can hit clear here. Let me see. There's the eraser. So let's get this cleared up there. That one there. So now let's do the next one here. So I'm just going to get started on this and you can get it from there. So now this time we're going to add H2. So one of the rules on that sheet I had you put on is anytime you add a chemical, equilibrium, the reaction is going to shift away from what you add, just like over here. And the same thing's going to happen. If we add hydrogen over here, let's do this color. So we're going to add, I'm just going to say we put a big chunk, a big balloon full of hydrogen over here. The teeter-totter, if you like that analogy, is going to tilt like this. It's going to go down, which means to get back to equilibrium where it's flat, you have to start shifting things. Yeah, you got it, that way. So that's how you do these. And if you're shifting in this equation, equilibrium to the right, you're going to make more of this stuff. And oh, you know what? Yeah, I think in past years, and I just had everybody change this to heat over here. In fact, that's what I'm going to do now. We're not going to cross this off. We're going to say this column is heat. So is the heat going to increase or decrease? Oh, yeah, that's right. So take that off. Let me get rid of this. Okay. And if you've got a line there, that's okay. So in this first one, if we're shifting to the right, yeah, we're going to get more heat over there, okay, on that first problem. We're going to get more heat. It's going to get hotter, okay? So then you can, there we go. So there's getting started. Okay, I forgot how to stop this. Stop sharing. Okay, bye, everybody. Oh, by the way, there's one of the paintings my dad made. He was an artist. The angle's bad. Anyway, toodles.